So in this first day of review for Chapter 10, Conics, we are going to focus on parabolas and circles. And the first questions here ask you to identify the shape based on the equation and then list the appropriate key features, such as vertices, covertices, foci, center, radius, asymptotes, and directrix, and then to graph it. So it is important that you know which of the key features go with which shape. All right, for the first one, we have x minus 7 quantity squared equals negative 20 times y plus 2. One of the clues that this is a parabola is that it has one squared term, but the other term is not squared. All right, so we have a square here, but not here. All right, so it is a parabola. And in order to graph a parabola or list its key features, we would need to know the value for P, and we would need to know where the vertex is. We can find the vertex from a parabola. It's just our h and k values. So in this case, our vertex would be the point 7, negative 2. Okay? And then the second thing that we need to do is we have to find P. And in our equation, our 4P from our generic equation is being replaced with a negative 20. So if we divide out our 4, that shows us that P has to be negative 5. Okay? Analyzing a little further, we have an x squared kind of parabola. And x squareds are the ones that open either up or down. And because P is negative, we know that this is going to have to open down. All right, so going to our graph, we have a vertex, we said, at 7, negative 2. Okay, there's our vertex. We know it's going to open down from there. And we know that P is negative 5. So that means our focus is going to be 5 spaces below the vertex. Okay, so there's our focus. Coordinates for that point would be 7, negative 7. And then because the focus was 5 points or 5 spaces below, the directrix is going to be 5 spaces above. So from our vertex, if we go up 5 spaces, this would be our directrix, which would have equation y equals 3. Okay? And then the last thing we did was we looked at how wide to make the parabola. So to get a good graph, we would need to look at our focal width. And our focal width is just that absolute value of 4p. So in this case, our focal width is 20, which means we are going to split that and put 10 on either side of our focus. So from our focus point, we would want to go 10 in each direction. Okay, which puts us there, and it puts us off my screen for on the other side. But we would have a parabola hitting that point and then again going the same spacing on the other side as well. All right, take a look at the second one. We are given x minus 3 quantity squared plus y plus 2 quantity squared equaling 16. Looking at its features, we're comparing this. We have an x squared basically plus a y squared equaling, in this case, a constant 16. That would be our radius. So this is a circle. And the key features of a circle, we would need to know its center and its radius. So the center is just our hk values again. So in this case, we would have a 3, negative 2 for a center. And based on this being our r squared, that tells me that the radius would need to be 4. All right, so going to our graph, we have a center at 3, negative 2. And we are going to go 4 spaces in all directions. And then draw in our circle. All right. Our third example. we have y minus 4 quantity squared equaling 12 times x plus 5. Again, notice that there's one squared term and the other one is not. So this is a parabola. Looking at our equation, we need to find our vertex, which we said was hk. Be careful here because your h value is actually the 5 in this case, or the negative 5. So our vertex is going to be the point negative 5, 4. Okay? And then based on our equation, our value for p, we've got 4p equaling 12, so p would have to be 3. It is a y squared kind, and our p-value is positive. So we are going in a positive direction. Y squareds are the left and right kind, so this one is going to have to open to the right. All right, so plotting our vertex at negative 5, 4. We are going to go 3 spaces to the right to get our focus. So our focus would have coordinates negative 2, 4. And then if we went 3 spaces to the right to get the focus, we're going to go 3 spaces to the left to get the directrix. So there's my vertex, my focus, 3 spaces to the left. Puts me there. We're going to have a directrix with the equation x equals negative 8. And we know that our graph opens to the right. Our focal width is this 12. All right, and we're going to split that and do half on either side of our focus. So we're going to go 6 spaces up. Oops, sorry, from our focus here. And 6 spaces down. And draw it in. All right, questions 4 and 5 ask you to write an equation for the conic from the characteristics that we have listed here. We're told it's a parabola. We are told it has a vertex at negative 3, 5. Okay, so let's plot that. And we're told it has a focus at negative 6, 5. So from that information, because our vertex, to get from our vertex to our focus, we have to go to the left. We know that it's going to have to open to the left, which means it's a y squared kind. And it means that our p-value is going to have to be negative. Okay, so p is going to have to be less than 0. How many spaces are we from going from the vertex to the focus? We had to move 3 spaces to the left. So p is going to be a negative 3. We know it's a y squared kind, so we have our basic equation, y minus k quantity squared equals 4p times x minus h. And we can just dump in our numbers now. So if we put a negative 3 in here for p, we're going to have negative 12. We need x minus our h value, which is this negative 3. So x minus negative 3 is actually going to be x plus 3. And on this side, we have y minus our k value, so y minus 5. Example 5, we're looking at a parabola. It has a vertex at negative 4, 5, and a directrix at y equals negative 7. So let's plot our vertex. All right, negative 4, 5, and then directrix is down here at negative 7. Okay, so we need to figure out how far did we go from the vertex to that directrix. We went up 5 spaces here, we went down 7 spaces there, so we have a total of 12 spaces. So that is the value for p. Now remember, p is a directed distance. So to go from vertex to directrix was going down. That means to go from vertex up to focus, we would have to be moving up. So we know that p is going to have to be a positive 12 to move us up to that focus point. All right, and that's all we need to write our equation. We've got h, we've got k, and we now know p. Because we are opening up from our vertex, around our focus, away from that directrix line, we know that it has to be the x squared kind. So we're going to start out with x minus h squared equals 4 times p times y minus k. All right, and let's dump in what we know. Our p value is 12. We have an h value of -4, and we have a k value of 5. So simplifying this, we would have x plus 4 quantity squared equals 48 times y minus 5. All right, our last question here is a distance and midpoint question. We are looking for both distance and midpoint between the ordered pairs -2, -6, and 3, -4. So remember our distance formula? It's the big long square root one. So in our first one, we have x2 minus x1, and then in our second, y2 minus y1. We need to find those differences, then we need to square those amounts, add it together, and the final step will be to square root the whole thing. So let's plug in our numbers. In our first one, we have to subtract our x's. So let's take our x's, 3 and -2, and subtract. So 3 minus a -2. And in the second one, we're going to subtract our y's. So we have -4 minus a -6. Simplifying, in the first one, we end up with 5 getting squared. That's 25. In the second one here, we have -4 plus 6. That's 2 being squared is 4. So we end up with a distance of the square root of 29, which is going to be something a little bigger than a 5. All right, and then midpoint, our formula is to average the x's. So we're going to take x1 and x2, add them together, divide by 2. And then we're going to do the same thing for our y's. y1 plus y2, average them out. All right, so plugging our numbers in again. Went too far. All right. Our x's, we have a -2 and a 3. Our y values, we have -6 and -4. All right, so simplifying this, -2 plus 3 is 1. We get 1/2 for the x coordinate. And on the other side, we have -6 plus -4. That's -10 divided by 2, or -5 for our y coordinate. And that would be the midpoint of that segment. All right, so for homework today, you are going to look at reviewing parabolas and circles and the distance and midpoint formula. It is kind of spread out throughout the chapters, so make note of the pages and which questions you are working on.